Kick a go.
Recording now.
Right, in 1978, and they decided the computer revolution was commencing, and you were asked to come and start that for bedding in Queensland.
I applied for a job with automatic totalisators. I was interested in the many computer systems of the time. There were microcomputers at the time. There was no such thing as a home computer. General knowledge of computers did not exist at all at the time, except for people who worked in the industry. The microcomputers were too slow at the time. The high input capacitance of the gates limiting clock speeds, and they were relinquished to the role of device controller, and in the ticket issuing machines with that system, and then at 6800 control the ticket issuing machines. The other thing that attracted me to the job was that the maintenance required was component level maintenance. It was not so problems were isolated not only to a module or a printed circuit board or a but it was had to be identified to the component, whether that be a thyristor, transistor, diode, capacitor, resistor, inductor, or an integrated circuit.
Stop there for a sec. Jimmy! Jeez, shh, stop that. Sorry, mate.
That's all right.
Okay, so when you did get the job and the whole lot, everything else, what was the criteria? What was the first meeting like? What were they trying to achieve?
The first meeting. Some background behind this project. The Brisbane project existed in the background of a much larger project, the Sha Tin project. And when that project failed, the Brisbane project was catapulted to the company's most important project, as there were clauses in all following contracts stipulating that it was dependent on Brisbane working. So
that's obviously well, shit hit the fan there all of a sudden. People had to pull it, to get this up and running. There would have been some anxious moments.
So what that ended up in was that massive amounts of overtime were worked because it was running behind time, and that left us having to integrate with the race club management as best we could. This massive amount of overtime impacted mainly on the racecourse managers, and they had to rise early in the morning and were early to bed, and we were a nuisance on their racetracks, and they would inform us early in the evening that they were now letting the dogs out. These systems were mobile. They were in semi-trailers, and come late at night and early in the morning when we had to leave, we'd open the semi-trailer door a crack and peer out to see if any evidence of the dogs. We exited the van and closed the door quietly and as rapidly as possible. This was no simple feat. There were large, heavy doors with heavy locking mechanisms and heavy hinges. They tended to squeak and clank, but we got pretty good at that. And then we'd race over to a nearby fence, and this was general throughout most of our customers, and one would clamber up to the fence and the other would pass the briefcases up. They would be thrown down on the other side, and then the final one would jump up on top of the fence. And I can remember many occasions straddling this fence, thinking to myself, when I joined the computer industry, I never imagined exiting work would be anything like this.
Dog bites were the criteria of it.
We never actually got any, fortunately. There are other recollections. As you mentioned, the systems were cantankerous, not so much from their manufacture, but because of the mobile aspect of operation, the vibration causing additional maintenance problems, air conditioning that that struggled during the hotter summer months, and the fact that the system opened when it was in need of significant additional work. And the chief programmer used to pace in front of the computer racks when the system initially opened, as this nature of the system, the cantankerous nature, made it an anxious time for anybody who was associated with it. He had this ability that I found quite amazing. He would always know when it was time to race over to the console terminal and frantically start issuing MCR commands. MCR was a command language of the RSX-11M operating system in use. And he would do this prior to the calls coming in from all areas to indicate the system was down. This ability led to intrigue on my behalf when I discovered that he could do this anywhere on the track and knew when it was time to race back to the vans without being told anything. I never discussed this for many years, as the demands of the system were such that we never had time for idle chatter. But I managed to talk to him years later, and he said the time to intervene in the vans was determined by the disk drives, and these were not the disk drives of today. They were compact for the time. They implemented a new recording method called modified frequency modulation that gave them a packing density of 5,600 bits per inch, and hence they were compact for the time, equivalent drives being the size of washing machines. They still weighed 29 kilograms, however, and had heavy positioner arms and positioner motor, and this clanked when the heads were moved from requested cylinder to requested cylinder. And the implication of this clanking ceasing was that the transaction file was no longer being updated, which meant we were no longer taking transactions, and that was his cue to go and race over and start issuing commands. And on the track, his ability to do this was determined by the length of the queues. He knew the maximum normal length of the queues, and if this was exceeded, he'd race back to the computer systems.
Would you, I mean, in those days, the early days, racing here at Eagle Farm and let's say somewhere else 50 miles away, so you, at the last race here, you'd, clean out the computer, do whatever you need to do, unplug and then quickly drive to the next one?
There were two semi-trailers. Each
right.
contained a full duplex PDP-11 totalisator system. So where there was two meetings in a day, yeah, there was one at each track. But yes, they had to move around the countryside for other meetings.
So you got to the track, plugged it in, plug the power cord in and go bang, and it went...
There were many problems induced in the system associated with the mobile aspect. The vibration caused problems. Even today, a major percentage of all electronics problems are contact related. As mentioned, these many computer systems were hardware intensive, so they had lots of contacts, and the vibration caused a lot of additional problems. And then there were...
was there any transportation, like, you know, you drive out a corner here, someone could run into the truck and the truck's in an accident? So
we were very concerned about the possibility of an impact. As I mentioned, the vibration did cause additional problems, so an impact would have been quite devastating. I think fortunately that never happened. We did have a couple of instances of interesting events. The primary movers not only moved the computer trailers from track to track, they also moved the Rolls-Royce standby generators. And in transit, bringing one of these generators back from Ipswich to the metropolitan area, one of the technical staff in the prime mover turned to the other who was driving and announced, "Isn't that our generator passing us?" A weld had failed in the coupling. And then on another occasion, one of the technical staff was driving the semi-trailer and transporting the computer trailer from one track to another, and the prime mover suffered a tail shaft failure. He pulled over to the side of the road and ran into a nearby pub to call for assistance. Yes, long before the mobile phone. When he came out, he was greeted by an elderly gentleman who was waving a stick at him in the air, shouting, "Hey Sonny, was that your semi I saw rolling down the road?" And it was nowhere in sight. The handbrake that he had applied works on the flywheel, and because of the tail shaft failure, the flywheel was no longer connected to the main to the main wheels, and consequently it was ineffective. Fortunately, it hadn't gone far.
Probably at that stage you'd go, back into the pub and stay there the rest of the day. Don't worry about it.
I think that was a great temptation.
That's just outstanding. I mean, obviously, like, you know, no one at the track. If it's all working, all going well, no one at the track knows the pitfalls of trying to get these things up and running.
Yes, that's a rather interesting observation. As I mentioned, these systems were cantankerous, and that impact that had on us was that in the near decade that we operated these systems, we never lost the feeling when coming to work to operate it of what is it going to do to us today. And so the thing that made this a success was part of its architecture, partly due to the massive amounts of overtime, but despite that I think it still would have been a failure had it not been this aspect of its architecture. And it was designed as a loosely coupled multiprocessor, so it ran in hot standby, and you had two transaction processors, and in the event of a failure of one, the other could take the full load. And this part of its design actually was the saviour, because it hid that constant struggle we were in to drag it through yet another meeting from the outside world.
How long did this go on for until it...
Many years. A lot of work was done on the system. For instance, in the transportation, the cables. Anybody who remembers the PDP-11s will remember the Unibus cable, very large, heavy cables that existed in the base of these racks. They joined the processor to the expansion boxes, and they, in transit, they sat in the bottom of the racks along with other ribbon cables that connected mass storage devices to the processor and other communications cable. And the racks were a hostile environment, many sharp edges and jagged protrusions, and that caused significant damage to the cables which were jostled around in the transportation. So that sort of thing caused a lot of problems. Yeah.
No, that's good. No, I could understand that. So you think everything's nice and rosy till you get in the back and go, ooh, it's cut cables.
Well, the point was that...
but how did it, so when did it start to get easier for you? When was it all sort of networked?
Well, I think that the point there was, we were getting to that, and the installation, for instance, the racks, we talked about the hostile environment, we did totally reinstall the system. We took it out of, we got a period where we could take one van out and totally reinstalled it and reworked the racks, and there were lots of improvements in the system that were done over the years. And the air conditioning was a significant problem, as I mentioned, with the struggling air conditioning during the hotter summer months. And the semiconductors, the building blocks of these systems, suffer from a condition called thermal runaway, which is fatal if you don't control the high level temperatures within certain threshold limits. So we got new air conditioning eventually. And
so I guess, as you say, you could take one out of commission for a while, and as technology progressed, you progressed with it.
Yes, well, actually, this is just work making it more reliable. Yeah. Actually, it's not introducing new technology at this stage, just making it more reliable. And I might mention an incident talking about temperatures and talking about the times that general knowledge of computers and, in fact, electronics did not exist at the time. We had one of these events where the air conditioning was struggling during a hot summer day, and we'd done everything we could to control the temperature. We'd thrown open all the doors, we'd scrounged additional fans to try and move the air through the computer room, and the branch manager at the time started to wave his hands around and shout, "Hose it down, hose it down." And I similarly started chasing him around shouting, "No, no, anything but the water." But to my mind, that just demonstrated the sort of knowledge of computing and electronics in general at the time, which now everybody sort of takes for granted, and everybody's got a computer at home, and everybody has quite a considerable knowledge of these things.
I mean, but making the process of equating all the totes and everything else, this must have been a vast step forward than what was there the previous decade. And decade after decade, it got better and better.
Well, that's right. I mean, this computer system we're talking about replaced Julius tote, so that was a significant improvement. I might say, talking about the impact of that system, like its predecessor.
Oh, okay. Stand by.